record, share the screen. So hopefully you've done the reading, textbook chapter 3 through the end of the section on compound light microscope. We're going to be talking about microscope basics today. Any questions about the schedule? All right, not, I'm just going to dig right in. Let me see, is there anything I should talk about with the class? Let me look at the website here just a minute. A number of people have emailed me their project for the infectious disease report. A couple of people, I had to tell you that that topic had already been taken. I think most of those gotten back to me. I have not had a chance to look at my emails today because of a problem with the student that got kicked out of the class, and I had to get them back in. So the worksheet for today is due October 2nd. The worksheet for both lab 2 and all future labs, including today's lab, will be worth 5 points. All right, let's go on to the project or the lab. Just looking to see if there's anything I needed to talk about. There was an extra credit assignment. Let me remind you that if you want the extra credit point for doing a study group, find a student in the class or in some other microbiology class. Just let me know if it's another student from another class. And then submit to me who you studied with, for how long you studied, and what you studied. Add your name and the name of everyone in the group. It has to be a full name, by the way. And then I'll get you an extra credit point. And that's due this Saturday as well, October 2nd. It looks like you can no longer take the practice quiz. But it could be about the, let me check that. I might have the date different than the last date possible. Let's see if that's in here. No, it looks like I'm showing the correct answers on October 1st. So you probably are, yeah, it had to be done by September 29th. All right, I think I'll close that. And let's talk about the lab now. So read the lab module and the textbook chapter 3 through the end of the section on the compound light microscope. You're not physically going to be using a microscope in this class. However, upon completion of the lab module, you should be able to locate and name the parts of the compound light microscope along with describing their functions, be able to calculate the total magnification for each objective used, know the guidelines for focusing specimens with different objectives, meaning the guideline for using the scanning objective, the low power objective, the high power objective, and the oil immersion objective. Be able to estimate the size of a specimen when seen at different magnification powers, meaning by seeing the field of view of each objective, you will be able to know how big that field of view is, and then determine how the specimen is in comparison to the field of view, and then you'll be able to get an estimate of the size of the specimen. Understand the rules for proper microscope care and define the terms associated with the microscope. Any questions about any of that? All right. I need to make this a little smaller so I can get this. There we go. That's a little better. Memorize the name and the function of the parts of the microscope shown on this page. Oops, just lost it. Problem is I did the scroll over here. I have to do it here. So you should know what these are: the eyepiece or the oculars, the objective lens, and altogether it's the revolving nose piece for the objective lens. And each lens, like that would be the 4X lens or the scanning objective. That one right there will be the oil immersion lens. And I can't see clearly the other lenses, but there are 2 other lenses. Oh, shoot, I keep doing that. How do I get rid of that? I'll stop doing that. Oh, I got a lot of things open. Should close some of these things. The stage, which is 3, the clip holder for the slide holder, which is 4. No, this is in the way. I don't see 5. Is anyone there? It is right there. That moves the slide. What is that called? I forget. Mechanical stage control knob. 6 is the iris diaphragm, which you can't see very well, but that's the clip that's pointing out there. 7 is the condenser. 8, the large knob. Coarse focus. 9, the fine focus. 10, the switch for turning the light on and off. 11, the rheostat, also called the light intensity dial. And then 12, the lamp or light. So there they are there. You should know them and what function they do. You should also learn this table. You don't really need to know the name of the lenses, although it won't hurt you to learn them, because I tend to use the lenses by their power. So I'll call one the 4X lens. That's the scanning lens. The 10X lens is the low power lens. Note that when we're talking about the low power lens, it is not the lowest power. That would be the scanning lens. And then the 40X lens or objective is the high power objective, and it's not the highest power. The 100X lens is the oil immersion objective, and it's the highest power. You should know the total magnification. The total magnification is 10 times the power of the objective lens. Now you get the total magnification is you magnify, you multiply the magnification of the ocular lens, which is right here, with the power of the objective lens, which is right here. And so the compound microscope will magnify the objective with 2 lenses or 2 times, one with the objective lens first, and then with the ocular lens or the eyepiece second. All of the microscope in our lab, meaning at Clark, have a 10X objective lens. No, 10X ocular lens, sorry. Meaning we all have the same ocular lens. The best microscopes, which we do not have at Clark, can have a 20X ocular lens. Any question about that? So the total magnification, the objective lens times the ocular lens. And in our class, the ocular lens is always 10X. So the total magnification is 10 times the power of the objective lens. Any question about that? You should know the depth of field of the different lenses. The 4X lens has the deepest depth of field. That means on a three-dimensional object, you can see the entire depth. As you go up in power, that depth of field decreases. See if I can describe this. So instead of the entire depth of the object, you would only see part of the object. From the top down, I don't know, halfway, something like that. And that we say moderate. Small depth of field is the 40X lens. And then the very narrow depth of field, the 100X or oil immersion lens. With that one, what you're seeing is only one plane of the object. I can't show that well. They're kind of there. So instead of seeing the entire depth of the object, you're only seeing one plane of the object. So it's very narrow, the depth of field with the oil immersion lens. The same is true with the field of view. The field of view is how much of the slide you're viewing under the microscope. With the 4X lens, you have the biggest field of view. Get that over a little ways. So you see the largest field of view with the 4X lens. As you go up in power, you go like that, that field of view decreases. And then higher in power, it decreases further until the very smallest field of view, the oil immersion lens, you're only seeing a pinprick of your field. Any question about that? Some comments about the different lenses. The easiest one to use is the 4X lens because it has the largest depth of field and the largest field of view. The hardest to use is the 100X objective lens because it has the most narrow depth of field and the largest, smallest field of view. Any questions about any of that? Because this is the easiest to use, you should start with the microscope with this lens because you're most likely to find your specimen when the depth of field is deepest and the field of view is largest. And then the hardest one would be to use the 100X objective lens. All right. Let me see if I can shrink that. What did I do here? That's better. When you're looking at an image under the microscope, not only is it magnified, but it is also inverted and reversed. So the letter E will be larger, but its orientation will be different, meaning it's inverted and reversed. Any question about any of that? When we're discussing the iris diaphragm, you should know that it can be opened. Oh gosh, my hand isn't showing there. There it is. Open or closed. And you can use that to allow how much light gets through to the specimen. More importantly, you adjust the iris diaphragm so that you get contrast between the image and the background of the slide. And because of that, we say that the iris diaphragm is the most important for controlling the light. Normally, when you're starting, you have the iris diaphragm fairly open. And as you go up in power with the lens, you shut the iris diaphragm down. For best illumination, you want the iris diaphragm open to about the same size as your field of view. And that means with the 4X lens, you have the iris diaphragm open the greatest, and then you shut the iris diaphragm down as you work your way up on the objective lenses. So the iris diaphragm is the most important tool in light adjustment. The other tool that adjusts the light is, of course, the rheostat. And as you're shutting down the iris diaphragm and you're increasing the objective lens, you got to shut down the iris diaphragm. You may need to increase the rheostat because as you shut down the iris diaphragm, you're having less light come through the microscope. So when you first use the microscope, you should start with the scanning or the 4X objective. Turn on the light, place the slide on, or you might do that beforehand. Use the mechanical control knobs and use the coarse focus to bring the specimen into view. Once you have it in view, then use the fine focus to make it perfectly adjusted, the focus perfectly adjusted. From now on, you should not ever use the coarse focus knob when you're switching to higher power objective lenses. So when you switch from the 4X lens to the 10X lens, our microscopes have parafocal vision so that they should be in focus or close to it when you switch from one lens, objective lens, to another. And then all you have to do is adjust with the fine focus. If ever you use the coarse focus, you throw it off. And what you should do if you throw it off is don't start all over again. Start beginning with the 4X lens and focus in with the coarse adjustment, and then move to the fine focus, and then move up to the next higher lens. And then from here on, only use the fine focus. Okay, any questions about that? So the coarse focus should only be used with the 4X lens. Now, before you switch from one objective lens to the next higher lens, you should move your specimen towards the center of the field of view. I have this chocolate bar, move it to the center of the field of view. The reason being is that when you go up in power, like if we had the specimen we were looking at way down here in the corner or any place off to away from the center, the 4X lens has the largest field of view. Trying to do this, not close enough. I'm trying to make it, I can't seem to get it at the right angle here. Close enough. All right. And when you go up in power, you're going to reduce the field of view. And so what used to be in the field of view is now out of the field of view and you can't see it. So you need to move your specimen to the middle of the field of view before you go up to a higher power objective lens. Any questions about that? And then repeat the steps 9 whenever you go up to the next higher powered lens, meaning move the specimen to the center of the field of view, fine focus, and then move up to the next higher power objective lens. When you come to the oil immersion lens, you should realize that it is special and you have to add a drop of oil. If you don't add the oil to the oil immersion lens, it's no better than the 40X immersion, the 40X objective lens. And it's much easier using the 40x objective lens than the 100x objective lens without oil. So I would only use the 100x objective lens if you're adding oil. There's a special technique for adding oil, and I guess I'll talk to you about it right now, and that is you rotate. Let me see if I get two of these things. You rotate the objective lens halfway out and then the oil immersion way halfway in, but not in, so that it's halfway in between. And then you can bring in your drop of oil. Put a single drop of oil on the slide, and then move the oil immersion lens into the oil. Whenever you're using oil, you have to clean the lens and clean it with a piece of lens paper, and only lens paper. Don't use any other paper to clean it. You could use cloth, but I doubt most of you are going to want to have oil on your clothes. So only use lens paper to clean the lenses. Why we use lens paper is that it's special paper that has had the wood fibers removed from the paper. And wood fibers will scratch the lenses and do damage to the lens. And the lenses are the most expensive part of the microscope. So you don't want to damage them. And then again, if you do damage them, you're going to have to live with a damaged microscope. So only use lens paper to clean the lenses. We do have a lens cleaning fluid, which you guys have to really ask the instructor to get and use. And usually I would be the one using that and cleaning the microscope with that. But we do have a lens cleaning fluid for cleaning the lens too. And it's true with the ocular lenses, you could clean them with the Q-tip, but generally you guys will only be cleaning them with lens paper, especially since this is going to be an online class and we're only discussing it online. Why we use oil is that it has the same refractive index as glass. And so the light, when it hits the slide, will bend at the glass. And when it comes out of the glass, it will bend again. And then when it goes into the ocular lens, it will, not the ocular lens, the objective lens, the light will bend again. And each time it bends, you can lose some light. If the light ray is bent away from the objective lens, you lose that light. And when we use oil, it means between the specimen and the microscope, it's all one refractive index. And so none of the light is being bent, none of the light is being lost. And that increases the resolution or clarity of the image because none of the light is being lost. It's all being gathered by the objective lens. Any question about any of that? Now, when you're cleaning the 100x lens, which you need oil for that lens, you should also check the 40x lens, because if you rotate that lens through the oil, it'll pick up oil. And you might not use the 40x lens, but if you rotate it, you'll pick up oil. And if that oil gets on the 40x lens and then dries, it's hard to remove. So always check the 40x lens as well as the 100x lens when you're cleaning the microscope. All right, any questions?
Not yet.
Okay, thank you. Get too far, I think. All right, we've already discussed that. All right, so for some activities for today, because this class is online, you're not going to be performing any of these activities with the microscope. However, you will be expected to know the information contained in the table and how to use the formula below. You will be working with a microscope virtually online. So we have a little program where you will work with the microscope. And it's actually pretty good. It teaches you how to use the microscope. Go ahead and read over this material. This is what we would do if we were in the lab. And this is what you would do to get the information in this table. But we realize you cannot really measure with a real microscope. So we've filled in the information for you. The scanning objective lens is the 4X objective, objective lens. And its field of view, if you were to measure it, would be 4.5 millimeters or 4,500 micrometers. The 10X lens, 1.8 millimeters, high power 0.45 millimeters, the oil immersion 0.18 millimeters. And you need this table to answer some of the questions that we ask you in the worksheet today. When you know that the field of view is 4.5 millimeters, that'll then allow you to make an estimate for the size of the specimen. For example, if the specimen were to fill up half of the field of view, you know that its size is 2.25 millimeters. Okay, so you use the field of view to get an estimate of the size of your specimen. You're not going to perform this activity, but you will be doing a virtual exercise. At the end of the document, we expect you to know and understand the material in this exercise. So go ahead and read through that. The making the wet mount, you're not going to perform this activity and you're not going to be tested on it. We just gave it to you for your own information. You hopefully, well, you guys probably did your preliminary class online also, so you've never made a wet mount. You're not going to be handling real microscopes, but you are expected to know how to correctly store a microscope. So when you're putting away the microscope, you should lower the stage completely, remove the slide and put it away. If you used immersion oil, you should move all oil from the 100X lens and check the 40X lens using only lens paper. Do not use chem wipes or other paper. Make sure the 4X objective is locked in place before you put the microscope away. Switch the light intensity to minimum, turn off the light, unplug the microscope, and wrap the cord neatly around the microscope. We don't do that in my class. Support the microscope. That's something I should have discussed earlier. Whenever you're carrying the microscope, you should support it with one hand underneath the microscope and the other hand on the microscope. You can have the other one on the microscope holder or on the arm of the microscope. Let me show you. So you should have one hand underneath the base of the microscope and then one hand. We're not seeing the microscope holder in this picture, but it's back here. And you can also hold the arm of the microscope, which here would be right there. So have one hand there or where the holder is, and one hand underneath the base whenever you're moving the microscope. The reason for two hands is that microscopes are expensive, and if you somehow lose it with one hand, you got the other hand as a backup. All right, where were we? And then place the microscope back in the cupboard that you got it from, and put it back the same way it was put in. Usually the eyepieces are facing out towards you. All right, that one's not relevant for you guys. Overview of the terms, know the terms of this lab on the microscope. And then do the laboratory exercises. There's video clips, 2 video clips using the microscope and then putting oil on the microscope. Practice your microscope skills by using the virtual microscope. When you click this link, know that it's slow to load. Especially if you have a slow internet connection. And then use the program. Let's go back to here while that's loading. Practice naming the parts of a microscope on microscope labeling. And then answer the questions in the worksheet, not here, and turn in the worksheet questions. All right, let's go to, where to go? Oh, there it is. Still hasn't loaded. So there's the microscope. Select the option from the menu below to use the microscope. Where is the menu? I think you have to click on the microscope first. Oh, I see, it's just, there we go. So a guide, learn, explore is what you're going to be doing. Guide tip. So you grab a slide. Oh, that's kind of boring. Let's go to plant cell or something. Grab a slide and then focus. We're going to do the 4x lens. And then you need to do the coarse focus. So I'm adjusting how it's coming into focus. And that's too far, so about there, and then do the fine focus. And then move up in power, switches the lens. And then from now on, you only do the fine focus. It looks like I might need to use the coarse focus. Let me switch back. Normally you don't use the fine focus, but I mean the coarse focus, but it looked like in this case, I was off the scale. Yep, that looks like about fine focus. All right, any questions about that? Let's see.
No.
I think we're done, but let me check. So work on the questions and then turn them into lab module 3. All right. Get started. I'll be here until 8:20 to answer questions. Don't wait until 8:20 because when the last student logs out, I'm going to log out as well.
I have a question. So, for the question that says, well, let me find it again.
Okay.
Which objective lens provides the largest field of view? That's the lower power lens, right?
It's not the low power lens because that's the 10x objective. The 4x objective has the largest field of view.
Okay, the scan.
Okay,
Thank you.
all right.